All right, everybody, we're back for more. We're going to do another gas problem. I'm basing this one on Starboard from 1121, page 5. There's the actual activity. Here's ours. It's going to be a propane tank. Yeah. Some ATM. Okay. Heated. Yeah. Oh, we have a temperature change. That means that of the given information, you better be using the P1, V1 over T1 equals T2, T2 over T2. That's given. And this is a propane tank. You must know by Wednesday that a propane tank cannot change volume. So I want you to know that. And because of that, you can cross off volume. It's a constant. You won't be told that a propane tank's volume remains constant. You have to know it. And there you go. So which of these variables is the one being asked for in the question? P2. So I need multiply both sides by T2. I'm doing it right now. I know there's a lot going on all at once here, so I'm going to do it step by step down here. P1, T1 equals P2. T2 is what we have now. And I want to get rid of, I want P2 by itself. So I got to go on the other side there and get rid of T2. And now P2 is going to be by itself. And it's going to be T2 times T1 over T1. T's have to be converted to Kelvin. You're going to have to use this anytime for any gas problem. Correct. So I'm just going to go up here and add 273. And that is going to be T1. And that's going to be 298.12 Kelvin plus 273. This is going to be T2, and this is going to be 507.5. Is that right? Okay, that's a 5. Very ugly 5. Okay, and I got my, yeah, and now I can solve T2 in red was 507.5. This is going to expand, no, it's going to, pressure is going up for sure. Times P1, which was 0.9876 ATM, and the big K, 298.12. Not double, but getting there. See what I'm thinking? 250 would Kelvin on the bottom would be double. This is less than that. Yeah, so 1.7. I'm waiting. Maybe I'll pause. Sorry. We're back. She can't see to figure out the question because my face was blocking it. And so we're going to, sadly, we have to wait some more. 1 point, I guess 1.7-ish, maybe 6-ish. I don't even know. 1.8. And 4 sig bigs, is it? 4, 4, 4. Yeah, everything's 4. 4 is our default. 6, 8, 1 ATM. Final answer. Next up, we're going to do a PV equals nRT equation. Oh, we're not finished. I like not finishing. Sorry about the last video. In the accompanying document, the final answer was there. We never got to it on the screen during the video. This is not all the final answers. This is just the ATM answer. You have to be given, and you will be given this information. Here's how it will look on your test. 1 ATM equals 760 mmHg equals 760 torr. That's all you need. So whenever you figure out the 8 millimeters mercury, you also figured out the torr, didn't you? Yeah. Same number. We have a question. I could give you pascals and ask you to convert, but I decided I'm not going to. I know you did it probably in lab for a couple exercises. Or owl. Could be inches of mercury too. I think you used that one in lab, didn't you? Yeah, inches and millimeters conversion done. But I'm not going to make you do that.
Since they're the same number, you have to show the work for both.
No, you only have to show me the work going to either ATM or to Tor. Oh, sorry, either millimeters mercury or Tor. We already have ATM. So let's just take our 1.681, 122,568. Please use the unrounded version and then round again. Get rid of ATM, give me MMHG. And that's 760 for everyone. Is that right? That is correct. And what you got for me? That's with rounding? 1, 2? And that would not be millimeters mercury. And 4 sig is 1, 2, 7, 7, 7, 8, correct?
Yeah.
And you can also just write with it, just go like this. And there's your other two answers, right?
Is it possible on the first that you would give us ATM?
Oh, absolutely. He asked, is it possible on the test, if I give you millimeters mercury, that would convert to ATM? And yeah, yes. In fact, yeah. Our next example, we're going to do that. We're going to do a PV equals nRT question when we find one from our class item. I believe it'll be the next day's lecture. That's too much meat.